Majdi, keep with me. Okay.
Sorry, Mr.
No problem. Okay, guys. So another time, guys, for the last time, I will talk about motion. We will continue with knowing many things about motion, but not only motion. We will mix it with another things, with velocity. We will mix it with others, with one. Yeah, it means the position and so on. So motion, it is the change in the position of a body with time. Okay, so one the position changes with time. So this is a motion. Motion can be described in terms of the distance moved or the displacement. So when we took last time what is the difference between the displacement and the distance. Okay, and it's clear to you what is the difference between the displacement and the distance. Okay, so now I want to start giving you the types of motion. You will know, or you will all know what are the types of motion. The most important types are the translational motion. You will see that what is the translational motion and what is the rotational motion. Translational motion is branched into three branches. The rectilinear motion is when we move with a straight line. The curvilinear motion is when we move in curve when the motion is in curve, and the circular motion is when the motion is circular orbit. Okay, while when we go to the another type, that is the rotational motion, object rotates on its own axis. When we talk about axis, it is a rotational motion. One of you can ask me, what is the difference between rotational and circular? Circular is forming a circle. I will give you some examples now. But rotational is rotating around an axis. When we talk about axis, you know what is an axis? Guys, can you hear me?
Yes, Mr. I know it's
Yes, Mr. We know what
Okay,
axis
you know
is.
what is the axis. Suppose the axis of your bicycle, for example, so that when we say that the wheel of my bicycle is rotating around the axis, it is a rotational motion. Okay, and you will not now see what is the oscillatory motion. Later on you will see it when you will take another types of motion, but for you now, guys, these are the motions. What?
random motion. We will take it later.
Yes, you will take it later. Now you are responsible for these motions: rectilinear, curvilinear, circular, rotational motion, and random. Random, it's what's the meaning of random? In any way. Not all these motions. In any way, when you move, for example, the movement of the smoke and air is, we do not have a specific movement in any way. Okay, so that the air, for example, in the smoke in the air can move randomly. Okay, you know that here, for example, the difference between distance and displacement. Here, for example, if there is a lap, you know the lap. Okay, suppose in Formula One there is a lap. Okay, the car starts from here and returns to the same point. So the start and ending point is the same. So the distance covered, for example, here is 400, but the displacement, guys, is what? Who can tell me the displacement here is what? Here, if the distance
Mr.
covered is 400, but the
Can you repeat
displacement
what
is
is
what? Yes, I will repeat it.
I just
Guys, I'm talking about the difference between displacement and the distance, and we talked about it last time. Okay, the distance covered, for example, if we have a car starts from the starting point and returns to the ending point, that is the same as the starting point. Okay, the
this
distance
is the
covered,
distance.
the distance covered is what, guys? Total distance
400.
covered in one lap equal 400. But because we are returning to the same point, so what will be the displacement, guys?
Zero. Zero.
Excellent. So it will be 0. Why it will be 0? Because the displacement, it is the length of the shortest path. The displacement, it is the length of the shortest path traveled by a body from the initial position to the final position. So what is the initial position and the final position here? Is the same point.
0.
Okay?
Because
Because it is the same point, so that if we will know the shortest distance between these 2 points, it will be 0. Okay? You know the difference between the displacement and the displacement and the displacement and the distance. I will give you another example here. For example, here another example, but I will not give you a 0 value of displacement. See here, guys. This is a bicycle starting from here, going with their journey. He reaches the point, another point here, guys. Okay, suppose this is point A. Okay, this is point A, and this is point B. Okay, this rider starts from point A to point B, covering a distance. This is the distance, guys. 10, another 10, it's 20, 30, 40, and 50. So the distance covered is 10 plus 10 plus 10 plus 10 plus 10. It's 50 meters. But the displacement is the direct length between what and what, guys? Between point A and point B. So the direct length, guys, between point A and point B is 20 and not 50. So you know the difference between displacement and distance?
Yes, sir.
Okay, great, guys.
No,
You didn't understand the difference between displacement and distance?
Yes.
Okay, great. No problem. Hadi, if I am going from, this is point A, okay?
Okay.
And this is point B. I am going from point A to point B, but I cannot go directly in this way because this is the path here, guys. You can't see the path here, guys?
Yes, I can
Okay, this is the path. So I start from here. Okay, I reached this point, and later on I covered all this distance. Okay, and I count this distance. I see that this distance was 10 plus 10 plus 10 plus 10 plus 10. So my distance is what, guys? 50. But if I
50.
want to know, the displacement now between point A and point B. So if I want to know the displacement, I want to know the straight line covered, or the shortage distance. We call it the shortest distance between point A and point B. We just make a link between point A and point B. So this link will be the shortest distance between point A and point B, and it will be
But
the displacement. What?
So how could I?
Mister, didn't you say we can't go from here to here? How is the displacement 20?
We cannot go directly from here to here. I'm finding the displacement, the distance covered from A to B. This is the real distance, guys. Okay, this is the real distance. But I want now to know the distance. This is the real covered distance by the bicycle. But the distance that is actual distance in the map, let's say we have a map and this is the actual distance, we call it the displacement. Okay,
How we can calculate the displacement?
Yes, Mister. How do we calculate the displacement? How
we
did you
can,
know it's
I
20?
give you the value here, guys.
You give us the displacement?
Yes, I give you the value. I'm giving you an example. Why you make it hard for you? Okay, guys, I will give you another example. Suppose here we have, okay, this
Sir,
is,
can you tell me the name of the lesson again, please? If you can.
it's picturing motion. Okay, suppose this is, guys, here. Look here, guys. Suppose this is point A and this is point B. Okay, suppose I'm going from point A to point B. Okay, so we have here two things. We have a distance covered, so we call it distance D. So distance, suppose we have distance 10 meters. Okay, so if I have here distance 10 meters, because I am going from point A to point B, but with a straight line, guys, this is point A, this is point B. I'm going from point A to point B with a straight line. Okay, so here guys, the distance and the displacement is the same. Okay, why? Because the distance and the displacement are forming a straight line from A to B. But suppose another example here guys, I give you, let's say we move here with another path. Let's say I cannot go directly from here to here, so I will go another time, I will go in another path. I will go this way, another time I will go this way, another time I will go that way, and finally I will reach the point that I want. Okay, so I will see what is the distance between, what is the distance here between each point. Suppose this is point, let's say C, this is point D, this is point F, and this is point B. Okay, so if I want to go from A to C to D to F to B, this is my path. Okay, so that I can say, for example, this is 1, this is let's say 10 meters, this is 5 meters, 2 meters. Okay, this is 5, and this is 3. So let's see here guys, if I go from A to C to D to F to B, okay, we can say that my distance covered, I covered a distance 10. What is the distance covered here guys? If I go from A to C to D to F to B, I will
20.
start 10 plus 2 plus 5 plus 3. It will be what guys?
20.
It will be 20. So
20.
20 meters here guys. But what is the actual distance between A and B? It is 20 or 10?
10.
10. So the displacement is the difference in position. So the displacement between A and B is what guys?
10.
Is 10. But the distance, real distance covered is 10? No.
No,
Get
Mr.
it
It's
guys?
20.
What is the difference between when I say position, when I say displacement and when I say distance? It's clear guys? Can I continue?
Yes, Mr.
Yes, mister.
Okay, great. Now I will start with the speed, guys. It's an important term here to know what is the speed. So the speed of a body is the distance traveled by the body in a unit time. Okay, so this is the speed, guys. Speed of a body is the distance traveled by the body in a unit time. When we make a relation between distance and time, this is the speed. It's an important thing to know what is the speed. If a body travels a distance s, let's say the distance we call it s, in the time t, then the speed will be what guys? V, the speed, the symbol of speed is V. So V will be S over T, or let's say D over T. The distance is, sometimes we call it D, sometimes we call it S, whatever you want. Okay, the SI unit of the speed is meter per second. You know what is meter per second. Why it is meter per second, guys? Because distance is in meter and time is in seconds. So the SI unit of speed will be meters per second. Okay, or ms minus 1, it's the same, meters per second. Forget about this. Okay, since speed has only magnitude, it is a scalar quantity and it's not a vector quantity. Okay, it's a scalar. We cannot say that the speed, for example, is without giving it a direction, it is a speed. We will see what is speed with a direction later on. We will call it the velocity of the car, for example. You will see it now. Okay, you are okay with the speed, guys? You all know what is the speed. If you are driving a car, for example, you can say that my speed is, for example, 60 kilometers per hour. Okay, or if a rabbit is making a race, we can say that the speed of the rabbit is 3 meters per second, for example. Okay, so this is what we call it, the speed. You are all okay with the speed?
Mister,
Yes.
What?
why is it a scalar quantity?
Because we do not mention a direction. The difference between scalar and a vector, okay, is that the scalar we do not show any direction. I just say the speed of the rabbit is 1 meters per second, and that's it, without saying, for example, the rabbit moves with a velocity that is 1 meter per second to the right, describing a direction. I didn't describe any direction. I just give you the value, a magnitude, without describing the direction of the motion. Okay.
Okay, Mister.
Mister, I have a question, Mister.
Yes.
Mister, I still don't know what's the difference between scalar quantity and vector. Like,
It's
what
so
is
easy,
like?
guys. It's so easy. I will give you some examples, and you will ask your question. Okay, I want from you to ask your question. But after this, I want to know, Abdul Rahman is talking, or whom is talking?
Yes, Mister.
Yes, Abdul Rahman, focus with me. If I tell you, for example, now it's 10:09 a.m. So I'm telling you a value, or I'm describing you a position, or I'm describing a direction for you. Just I tell you that it's 10:10 a.m. So it's a scalar, or it's a vector.
I don't know, Mister.
You don't know. When I tell you, just telling you only a value, a magnitude, without giving you any explanation about it. For example, if I tell you the distance, or if I tell you, for example, the distance from Riyadh to Jeddah is 20 kilometers. So I tell you a scalar or a vector. I just tell you the distance between these 2 points, without telling you when you go from Riyadh to Jeddah to the east, for example. I mention for you the direction. So now I am telling you the direction. When I tell you the direction, so I am telling you a vector. When I tell you just a magnitude, so it's a scalar. So now you can make a small difference between a scalar and a vector.
Okay, Mister. Yes.
Another example, I will give you another example. These examples, when I tell you a scalar and a speed and velocity, when I tell you the speed, okay, the speed is, for example, the speed of the car is 50 kilometers per hour, and that's it, without mentioning anything in addition. So it's the speed without direction. Excellent. Without any direction, so it's the speed of the car. Okay, so it's the magnitude of the car, the magnitude of the moving of the motion of the car. It's a scalar quantity. Okay, but when I talk about the velocity, guys, so what is the velocity now? The velocity is a vector, and you will see why it is a vector. The velocity, guys, is the rate of motion. You will see what is the rate of motion. So it's the rate of motion of a body. Is more meaningful if we specify its direction. So when we specify the direction of a moving object, it's more meaningful than just saying, for example, I am moving with 30 meters per hour, 30 kilometers per hour, and that's it. 30 kilometers per hour in which direction? We cannot. When we specify the direction, so we are talking about velocity. So we are giving a vector quantity and not a scalar quantity. Okay?
Until now, the difference.
You didn't understand the difference between speed and velocity?
Yeah, no, between scalar and vector.
Oh, you understand the difference between speed and velocity?
I think so. Speed is with direction, without direction, and
yes, and velocity
with direction.
This is the difference between scalar and vector. Scalar is without direction. Vector is with direction. That's it.
Okay.
Scalar is a magnitude, just magnitude, without specifying any direction. But vector is specifying the magnitude and giving the direction. Okay? So
So can you give an example of velocity?
Velocity, yes, I will give now an example. Okay, the rate of a motion of a body is more meaningful if we specify its direction of motion along with speed. So I give the speed, I give the scalar, I give the magnitude, and indeed I will give you the direction of the moving object, so that I am giving you the velocity. So the quantity which specifies both the direction of the motion and the speed, it will be the velocity. Okay, so velocity is what, guys? Velocity of a body is the displacement of the body per unit time. So we can give you here, guys, the displacement over the taken time. If I say, for example, I am going from Jeddah to Riyadh, okay, the displacement is, for example, I will give you the example here, guys. Wait. Okay, suppose this is here, guys. I will give you another example. Okay, so this is 2 points here, point A, another time point A and point B. Okay, here I am taking the distance, first of all, the displacement. In order to find velocity, I need what, guys? I need displacement. Okay.
Displacement and
Yes.
speed.
So what? No, velocity is the speed. It's the same. But
Displacement over time taken.
Yes, excellent. Displacement over time taken. So let's say, guys, here I rest here for, while I have a journey from A to B, I rest here for 1 minute. Okay, so I start my journey here. First of all, from here to here, I rest for 1 minute, let's say, and another time I continue my path. Okay, let's say this. So there is a difference in time, so we cannot say that the time taken is the same. So what shall I do here? If I want to know whether I am going with what velocity, when I want when I want to find the speed, guys, the speed, we can see it where? We can see it on the kilometrage. You know the kilometrage, the kilometer that we use, that we see in our cars. So when we want to see the speed directly, we can see it using an instrument that will give us the speed directly. For example, 60 kilometers per hour. Okay, and that's it. Directly we can see the speed. But if I want to get, guys, the velocity, I want to know two things. I want to know the displacement covered here, guys. I want to know the displacement, and I want to know another time what? I want to know the displacement and the time covered and the time taken. Okay, so if I give you such an example, the displacement, guys, D equal, for example, 100 meters. Okay, and the time taken T, okay, equal the time taken T, let's say equal 500 seconds. So what will be the velocity, guys? Velocity is distance over
0.
distance over
It will be 1/5.
time. It will be, distance is what, guys? 100 over the time is what, guys?
0.5, Mr.
So now it will be equal what? 100 over 5. 100 over 500 is 1/5.
0.2.
Okay.
0.2.
Equal 0.2. What is the unit here, guys? Meter per
second.
It's hard, guys, or it's easy?
No.
Just giving the value of a velocity is putting the distance over the time. That's it. Okay, you get it? How can I get the velocity?
Yes, I get it. But speed is also meter per second, right?
Yes, it's the same, meters per second. Okay, you can put it meters per second if the distance is in meters, and if the distance is in meter and the time is in second, we can put it meters per second. If the distance is in kilometers and the time is in hours, we put it kilometers per hour, and that's it. Okay, clear, guys?
Okay, Mr.
Okay, great. Now you will not okay, now we already know how to plot point
Mr.
on
Can
a
you
graph.
zoom out?
What?
Can you zoom out? You are zoomed in.
You can zoom out on your phone. You are joining from your phone or from your laptop.
Yes, Mr. I zoomed out.
We already know how to plot a point on a graph. So let's recall them. Okay, suppose I want to plot point 3, 4 on the graph. You all know how to plot a point on a graph. It's so important, guys, to plot, because in velocity you will use this graph. Okay, why you will use this graph? Because when we say, guys, here, let's say here, when we say distance over time, so we are talking about distance. When we say distance over time, it means that velocity is the distance as a function of time. So if I want to
Mister,
draw what?
can I go to the bathroom?
Yes, but hurry up, please.
Okay.
So if I say here I want to draw the graph here, guys, I will draw it. No, sorry. Okay, so I will draw it in this way. This is the distance. Okay, this is the distance here, guys, per time. It will be distance, and always, guys, this is the way how can I draw my graph. Okay, this is the time. Can
you go to the toilet quickly, please?
What?
Can I go to the toilet quickly?
Okay, quickly. And when you return back, please let me know.
You are not recording. I want to tell you.
Yes, no problem. So this is, guys, what here, if I just record my distance over my time, so that I can see whether I am going in with a constant motion, or I have a uniform motion, or accelerated motion, or decelerated motion. We will mention them later on. What are the difference between acceleration motion, uniform motion, and deceleration motion. When I say, for example, here, I will put, this is the first point, this is the second point, third point, this is the location of my movement, guys, let's say. Okay, I start from here and reach the point. For example, I'm starting from point A. Okay, this is A prime, let's say. This is A double prime. Okay, this is A triple prime. This is an example, guys. Okay, so what shall I say here, guys? I'm moving with a speed, velocity v. Let's say from here to here, every time 5 seconds, I'm counting, or I'm taking a photo of my movement, let's say. Okay, and the distance covered here, guys, is always 1 meters. Okay, the same here, guys, from here to here is 1 meters after 5 seconds. Okay, and from here to here is 1 meter after 5 seconds, and the same here, 1 meter after 1 second. So if I want to know if I want to know in which motion I am going, in uniform motion, you know what is uniform motion? Guys, can you hear me?
Yes, Mister.
Okay,
Yes,
so
Mister.
when I go from point A to point A prime to point A double prime and reach the point A, 4 primes here, guys, okay, with the same speed. Why with the same speed? I'm covering the same distance, okay, with the same time. So if I want to calculate the distance, the velocity from A to A prime, let's say, okay, from A to A prime, it will be, who can help me? Go for it, guys. Velocity equal what from A to A prime?
It's 1/5.
Excellent. Distance over time. It's, guys, 1/5. This is we call it the instantaneous velocity. At this instant, the velocity was 1/5. But if I want to get a velocity between two intervals, always, guys, I will put this velocity. Focus with me, guys. It's an important class on velocity, by the way. Velocity is equal to what? Velocity is equal to delta. You know what is delta? Delta D over delta T. And you will see why I mentioned this. When I want to get the speed directly, I have 1/5, and that's it will be the speed of the car at this instant. When we talk about instantaneous velocity, it is the speed of the car at this instant. Instant means at this time the speed was, for example, 1/5. But when I want to know the velocity, it means I need here displacement, and I do not need just distance. I need displacement over interval of time, and not only time. So when we talk about velocity, it is displacement over the time, over the interval. So what is the displacement here from A to A prime? Who can tell me?
1.
What shall I do? Yes, it's 1. Excellent. But how can I know that it's 1? I will tell you something, that this is my zero reference here, guys. So here is my zero reference.
Yes.
I will put here, guys, from A to A prime is 1. So I will put here 1 minus 0 over, this is 1 minus 0. You know why 1 minus 0? Because I am putting here from A to A prime, that is 1. And another time from A to A, that is 0. Okay? Over, what is the time interval? In this at point A prime, at point A prime, what was the time, guys?
5.
5. Excellent. So 5. And at point A, what was the time?
0.
Excellent. So velocity here, guys, is also 1/5. Either if I use the displacement. So this is the velocity from A to A prime. Okay? I will solve another one so it will be clear for you. I will solve from A to A double prime now. Okay? So velocity from
No,
A.
Mr. Can you solve from A prime to A prime 2?
Okay, I can. Yes, A prime to A double prime, you mean? Yes?
Yes.
Yes.
Double
Okay.
prime.
We will solve it together, guys. Go for it. Now, if I want to know from A prime to A double prime, first of all, the displacement. So starting from 0, guys, from 0 to A double prime, how many?
2.
Distance
2.
is 2. Excellent. And from 0 to A prime, distance is what?
5 seconds.
I
Oh,
tell you
okay.
the
1
distance is what?
meter.
1 meter. Excellent. So this is 1 meter. So what shall I do here? What is delta D here? Almost the greatest minus the greatest
The
minus
lowest.
the smallest. So it will be 2 minus 1 over from A to A double prime. How many seconds it take?
10 seconds.
Excellent, excellent. It's 10 seconds. Okay? Minus from A to A prime. How
5.
time?
5
5.
seconds.
Excellent, guys. So it will be 1/5. Oh. Who can tell me? We have here same velocities, guys. This is 1/5, and this is 1/5, and this is 1/5. So who can tell me what is the kind of motion or what is the type of motion here? Uniform or accelerating?
No, Mr. It's
Uniform.
Excellent.
Mr. What's the
Excellent.
difference between them, yeah, Mr.
When we have a constant speed in all cases, constant speed without changing, if you get all these values, you will get 1/5. Okay, and try it, guys.
Mister,
What?
if we change the speed and the distance,
I will give you now an example. Now I will put it here, guys. Now if the same case, but from A, let's say to point B here, okay, covering the distance, let's say we cover the distance, this is point B, we cover a distance in the same interval, 5 seconds, we cover a distance, let's say 2 meters, okay? So what will be the distance
Okay.
here? That is the velocity now, what will be? Hurry up. From here to here, what is the
2
distance
over
here?
5.
Okay,
2
let's
over 5.
say, we cannot say 2/5, it's correct, but we will start from the 0 reference. So from 0,
Okay.
from 0 to point B is what? Let's count it. 1, 2, 3, 4, 5, 6. Okay? So it's 6
Okay, sir.
minus from A to A here, guys, is what? Let's count. 1, 2, 3, 4. So it's 6 minus 4. As you say, it's 2. Excellent. Over what, guys? Over the time. Here,
Sir.
the time here is what? From O,
Sir.
from A, sorry, to B is
25.
5, 10,
30.
5, 10, 15, 20,
25.
25. Excellent. So 25. But from point A to point A, 4 primes is 5, 10, 15, 20. So it will be, guys, 6 minus 4 is what?
2 over 5.
Sir.
2/5, and it's
2
not
over 5.
anymore. It's not anymore 1/5. It's 2/5. So the velocity here increased or decreased?
Increased.
Increased.
Excellent. So one velocity increased, we can say that we have acceleration. Okay, one from A to A prime to A double prime to A3 primes and 4 primes, we say that the motion is uniform without any increase in the velocity.
Sir, I have a
But
question.
from A 4 primes to B, we say here that the velocity increases, so we say that we have acceleration motion. Okay?
Okay, Mr. But I have a question, Mr.
Sir.
Yes.
Mr. We here said. Okay, Kareem.
Ask.
Sir. I have a question.
Ask for it.
Where did you get the 6? Can you show me? Because I kind of got confused a little bit.
One you get what?
The 6.
Okay. 6 is here, guys. Just counting from having the distance from A to B. Let's repeat. 1 from A to A prime 1. From A to A double prime 2, 3, 4, and we have here 2 meters. 4 plus 2.
Oh, okay. I understood it now.
Okay, great,
Mister.
great, guys. What?
But the delta, what we is the same, Mister. The delta for the distance and the time.
Yes, that always make a minus, a subtraction between the biggest value minus the value that is before it. Okay, if I want to know the velocity here, I make the delta that is the point B. We call it, for example, B, or from O to B minus from O to A 4 primes. Okay, this is the
Mr.
delta.
Can I ask a question?
Yes, you can ask.
Mr. Here we found the distance 2 over 5. What's
Yes.
the displacement here? What's the displacement?
No. It's not the distance 2/5. It's the velocity 2/5. This is the displacement. The displacement, I will put it here, guys. I move from point to point, okay? From this point to this point, I move, let's say, this is the 0, okay? This is the first one. This is second, this is the third, and this is the fourth. I want to know the displacement. It means the distance between this point and this point, okay? So this is the 0 reference, okay? This is the 0 reference. First of all, I want to know this displacement, okay? How can I know this displacement? I must know the distance from 0 value to this value. For example, 1, 2, 3, 4. Okay, so every distance here is 1, but let's say here. Okay, this is 1 meter. This is 1 meter. This is 1 meter, and this is 1 meter. Okay, from here to here is what? 1 plus 1 plus 1 plus 1 is what, guys? Help me.
4.
4.
It's 4.
4.
I want this distance. So it is 4 minus what?
Minus 1.
3.
As mean 3.
Minus 3. It's 4 minus 3, guys. This is the displacement. This is what we call by delta D. Delta D is D. Let's say this is point 1. This is point A, sorry. This is point B. Okay, this is point C. And this is point D. Okay, and this is point F. Let's say this. So the displacement is dF minus d capital D. Okay, this is what we call it by displacement. You get it, guys? Everything is clear?
Yes.
Yes.
Okay, please, guys, for today, check your Classera, because I want to post for you many of these exercises so that you can
You will
practice
send it
them well.
Microsoft Team or
No, and on Classera. I will
assignment
post them.
or
No, for today, the time is over. I would not give you any assignment. For next time, guys, I will post now on Classera. Today I will post some exercises so that you can practice, you can practice.
when will you post them?
What?
When will you post them?
Today I will post them so that you can, and the due date is for, in order to return them for me, is for Monday, okay? So that you can work on them in this weekend, or even on Sunday or Monday, okay? Till Monday 6 p.m. I will give you time, okay?
Bye.
Okay, everything is clear, guys?
Yes, mister.
You are
Yes,
great
mister.
today.
Thank
Have
you,
a nice
mister.
day.
Yes,
If
mister.
anyone have any question, please let me know. And you are great
Okay.
today, guys, by